Evening everyone, I'm Harika Reddy of Group 7A. My team members for this mini project are Suhita, Satvika and Laukeshri. We have made a project on smart exhaust fan for air quality monitoring using IoT. Our abstract goes like this. Every one of us are aware about the bad air quality results which leads to serious health problems in the industries, households and other areas as well. So our exhaust fan over here plays a vital role in extracting the bad odors or the impure air and bringing in fresh air, thereby improving the air quality. The application uses sensors like MQ135 for air quality monitoring and DHT11 for temperature and humidity monitoring, and the results are displayed using a serial monitor or a mobile application as an interface. So we have providing us with the very smart exhaust fan control option as well. This project is specifically to help the society to monitor the air quality and also help the users to automatically take required precautions to avoid any accidents or leakages using the IoT technique. Systems which are already there in the market are the traditional gas detectors, which are used to detect the gas levels in a particular area. They use different types of gas detectors according to the gas they want to detect it. We have sensors like MQ2, MQ135, which are used to specifically monitor them. And we also have existing exhaust fan, which is used to check the interior air quality and air temperature levels, and it also vents out the bad unwanted odors, moisture, particulates, smoke and other contaminants that might be present in the air. uh, but mixing or combining this, our proposal is that we have developed a smart exhaust fan to monitor air quality and temperature using IoT, which also provides us with the cloud option in the mobile application interface. And we can monitor the harmful gas levels and take required action appropriate or necessary at that point. And if the temperature and air quality goes beyond the threshold we have set, the microcontroller uses the mobile application Blink to display the details about the air quality and also add a cloud application to that. So the hardware and software requirements for this particular project are our smart exhaust fan we have utilized is a 12 volts DC exhaust fan, ESP32 Wi-Fi module as our microcontroller, and the sensors as I've previously mentioned, MQ135 sensor for air quality monitoring and DHT11 sensor for temperature monitoring. Software requirements are very simple. We are using the Arduino software application, and for mobile application interface we are using Blink. The project flow is quite simple here. We check on the temperature and air quality levels. Once they go beyond a threshold value, uh, it checks on yes or no. If it is a yes, the Blink app displays the values, and also the serial monitor will be displaying the messages. At the same time, the exhaust fan is switched on. It also updates the values continuously on the serial monitor and the app also. So the exhaust fan's state chart is quite simple. It works on the principle that once the values are above a threshold, the fan is switched on. They are below a threshold, fan is switched off. The sequence diagram goes like this. The sensors play the very vital role here. The very first task is that sensors have to check if there are any sensors and get the data extracted from them. In this case, it is air quality and temperature readings. Send them to the microcontroller, which is ESP32 Wi-Fi module, initialize itself and send that particular data to the app interface, which in this case is Blink application. There will be a user-friendly interface in Blink, and the continuous readings are displayed in the Blink application. It also provides us with the cloud option, and the exhaust fan is switched on or off according to the readings. So the classes used for this project are very simple. For the microcontroller, these are the uh, classes we are using, like begin or run. And for exhaust fan, we have to just remember that exhaust fan functionality is just getting switched on or off, and the Blink application plays a vital role here. So we use classes for Blink like begin, run, virtual write, log event, timer, etc. And the sensor data is DHT11 and MQ135. As you can see, the initialization process for both of them in the software basis is simple. Yeah, but architecture quite understandable at this point. We just take the readings from the DHT11 and temperature for temperature, and MQ135 for air quality sensor, and update the microcontroller every second, and then exhaust fan is turned on based on the readings. As you can see an implementation glimpse here, we have a 12 volts DC fan here, and we also have MQ135 and DHT11 placed on the breadboard, and they are directly connected to the microcontroller, which is ESP32 in our case. And the power supply, as you can see, is being sent through the and 12 volts adapter, which can be replaced with a battery as well later on if required. And the power supply is being controlled by relay, which is of 5 volts. Relay is playing a very vital role here, guys. Working of exhaust fan, here every sensor or relay you see, there is an LED being blinked here, which shows that they are under working. Even MQ135 and DHT11 show a blink like that using LED, and once the threshold is reached, the exhaust fan is switched on for that. The code is very simple. Once we upload the code and try to execute it, it runs in the Arduino software, and these are the results. The Blink application shows this kind of user-friendly interface where you can check the temperature readings, humidity readings, and smoke readings according to the threshold you have set. As you can see, once the code is run and uploaded, this is the serial monitor displaying air quality, humidity, and temperature readings, which in turn are switching on the exhaust fan. So the conclusion is that our smart exhaust fan system is very cheap, it is very affordable, and the design makes it very compact that it can be utilized in any kind of household with little to do space. And the relay here plays a very vital role and supplies the exhaust fan with power supply, which is also coming from the external source using an adapter we can replace it with a battery as well. So this option here is for a better environment and healthier environment to stay in. For future enhancements, there is a possibility that we can use something like smart scheduling, where you can pre-decide when the exhaust fan can be turned on, and we can also add something like voice control, mobile alerts and notification, which is very possible in Blink. Integration with smart home systems also plays a very easy role here, and we can even integrate it with air purifiers, which have similar functionality, so both of them together can perform even more better. Future references are here. Uh, these are the references we have taken. So for this project, we have our project guide, and Maunika ma'am, assistant professor from GRIT, and these are my group members. Thank you, guys.